Hello, everyone. Yes, results OP. Vedantu OP. yes, 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 yes. So ये है results JEE 2001 July attempt के. Yeah, this is JEE main 3, right? So I'm very very personally happy that physics में the students have done really awesome, right? These are all Vedantu students. Okay, 2021. Yes. So बहुत proudly I can say that all these students are Vedantu wave students, not even YouTube students. ये YouTube वाला account भी नहीं है. One more thing that I want to say that when I used to prepare for this examination और हमारे institute के बच्चे जब क्रैक करते थे तो हमें बहुत प्राउड फील होता था, है ना? तो आई एम श्योर कि तुम्हें भी डेफिनेटली प्राउड तो फील होता ही है और अच्छा लगता है ना यार कि जिस इंस्टीट्यूट से हम प्रिपेयर कर रहे हैं उस इंस्टीट्यूट से इतने अच्छे रिजल्ट्स आ रहे हैं, है ना? इट डजंट ओनली जस्ट गिव यू द कॉन्फिडेंस बट आल्सो इट गिव्स यू ओके दिस इज रॉन्ग परसेप्शन. अंशुम शर्मा व्हाटएवर अंशुम इज सेइंग इज द रॉन्ग परसेप्शन. मैंने कहीं भी ये लिखा हुआ नहीं देखा है और ना ऐसा है कि दीज आर ओनली टॉपर स्टूडेंट्स. ओके, सो गाइस दीज आर ऑल वेदांतु स्टूडेंट्स. ओके, यस. मैं किस इंस्टीट्यूट से था वो जानने का कोई बहुत एडवांटेज तो है नहीं, सो लेट्स नॉट गेट इनटू दैट. बट व्हाट आई वांट टू क्लैरिफाई इज यहाँ तुम देख रहे हो कि केमिस्ट्री में number of students who are getting percentile 100 is less. उसका रीजन ये है कि जो सब्जेक्ट इजी होता है, सब्जेक्ट which is actually easier to score, definitely has more competition. Okay, people who find subject which is very easy definitely will have more competition in that. Because of that, chemistry in general is very challenging to actually outperform others. Okay, sir, our teacher told us the same that all have come from toppers batch. I personally have not got any such information. Okay, ये मुझे लगता है कि subject to clarification है. I will also confirm this once again. I do not think that these are only toppers to topper batch students. That is a wrong impression. Okay, and why would we only talk about the results of topper batch when we have more students who have qualified for this examination? Getting clear, everyone? तो स्टूडेंट वाइज रिजल्ट तो नहीं है मेरे पास. दिस इज द ओवरऑल रिजल्ट व्हिच आई वांटेड टू शेयर विद यू ऑल. ओके, बिल्कुल नॉर्मल बैच के स्टूडेंट्स भी इन्वॉल्वड है इसमें, इंक्लूडेड है इसमें. ओके, एग्जैक्टली. तो आई वुड से if you want to seek negativity out of it, you can take negativity out of it. यार इन लोगों का हो गया, मेरा नहीं हुआ अभी तक, या मेरा होगा या नहीं होगा. If you want to seek motivation out of it, you can seek motivation, you will get motivation. So it is totally your perception how you want to look at the results. Am I clear, everyone? Okay, exactly. It's not about the batch, it's about you, it's about your teachers. Are you not happy with the batch that you are in? First of all, tell me that. Are you guys not happy with the batch that you are in? You are happy, right? And जब तक यहाँ से happy नहीं हो और convinced नहीं हो तब तक 100% नहीं दे पाओगे. और अगर हो तो फिर किसी भी बैच में हो यार, you will definitely be able to give your 100% and that's what matters. Okay, so remember that in your life in general, है ना? अगर नीरज चोपड़ा ने सोचा होता कि यार मैं यूएस से नहीं हूँ, मैं चाइना से नहीं हूँ, मैं जापान से नहीं हूँ, मैं गोल्ड मेडल नहीं जीत सकता, तो ऐसा होता क्या? तो हमें गोल्ड मेडल नहीं मिलता. गेटिंग? क्योंकि वही 3 कंट्रीज है जहाँ से ज्यादातर गोल्ड आए. सो रिमेंबर, योर लक्ष्य इज नॉट टू गेट इनटू टॉपर्स बैच, योर लक्ष्य इज टू क्रैक जेईई एग्जामिनेशन. दैट्स इट. ठीक है एवरीवन? इज दैट क्लियर? कूल. Yes, awesome. So let's get back to what we are up to. Hamari long journey marathon is going on. Welcome back once again and say hi to your class teachers, Gautam sir, Rishabh sir and Dev Chandan sir. Quickly say hello to your class teachers. Everyone, quickly say hello to your class teachers. We have a very 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 interesting session to follow और बहुत सारे questions भी solve करते हैं आज. Okay? Yep, absolutely. I had my evening snacks. I will have my dinner after the class. Yes. Okay, everyone. So you all know मैंने last time एक बहुत अच्छा तुम लोगों को एक बहुत छोटा सा crisp एक monologue दिया था. I told you people to not ask, not to write anything as greetings, hi, hello or anything in the doubt panel. Don't write that there. Also, do not ask your class teachers to forward your doubt by yourself. Your class teachers will be the best person to take that call. If they are not able to answer your questions, they will naturally forward it to me. Okay? Cool. Awesome. Cool. So everyone, let's start. Switching off the chat in 5, 4, 3, 2, and 1. Okay? हाँ, definitely we will talk in the end as always. मैं उसके लिए कभी मना नहीं करता. ठीक है? चलो then. Everyone, stop writing anything in the doubt panel. Hi, hello, anything. Don't write it there. Only ask your doubts over there. So everyone, let's start. A quick recap of what we did last time. So we started the chapter of circular motion, and we understood that whenever an object will move in a circular path, there are only two possibilities. Either it can go in anti-clockwise sense or in a clockwise sense. The distance of the particle from the fixed point is the radius and is also seen as the position vector. Okay, and when the body is moving, say if I'm considering the body to be moving in anti-clockwise sense, then at any point, if you go and try to look at where the body is heading to, you just have to draw the tangent, and that tangent will give you the direction of the velocity of the body at that given point, right? And also, we realize that if the body will come back to point A, its linear quantity of displacement will become 0. Also, it is difficult to actually talk about the linear quantities only when the body is being said to be moving in circular motion. And then we came to an understanding to define angular physical quantities. So we realized that circular motion can be actually vectorially compared with a straight line motion. Yes, because in straight line motion there are only two possibilities for motion. Either body goes forward or body goes backward. Right? Forward and backward are the two possibilities in your 1D motion. Similarly, in circular motion are only two possibilities. Either go clockwise or go anti-clockwise. So that is why the idea clicks that we have to define angular physical quantities, in which angle will be defined as angular displacement. The way angle is being covered is seen as the angular displacement. The rate at which angle is covered is defined as the angular velocity, which you see written over here as the rate of change of angle. Okay, and if omega is also not constant, it is changing, then we define angular acceleration. So basically, we have angular displacement, we had angular velocity. Okay, so I will just write down angular displacement also. Angular displacement was theta. Then we talked about angular velocity and eventually angular acceleration. So everyone, if we have angular acceleration alpha being a constant, that means what? When the omega of the body is increasing at a constant rate, then these three equations of motion become applicable. Remember that these three equations are only applicable when alpha is constant. Otherwise not. Otherwise you have to take help of calculus And if the omega is constant, then alpha becomes 0, and then the life is much more simpler. Okay. Then after understanding all the angular physical quantities, we did our discussion of linear acceleration. Yes, we did a discussion of linear acceleration, and we realized that acceleration can be of two components, or that there are two directions in which I can resolve the acceleration of the body. Okay, that means what? If I say that when the body is moving in the circular path, this is the overall acceleration of the body A. So we can actually look at it to have two components and specifically perpendicular to each other, right? So one of the components that you see here is heading towards the center, and precisely the name of that acceleration is also given as centripetal or radial acceleration. The other one actually is going to be either along the direction of velocity or opposite to the direction of velocity, will be called as the tangential acceleration. So what is tangential acceleration? It is basically the rate at which speed is changed. This is speed, okay, not velocity. That means the magnitude of velocity. If magnitude of velocity increases, you're actually having an acceleration, tangential acceleration in the direction of velocity. If speed is decreasing, acceleration at tangential acceleration will be opposite to the direction of speed or velocity. And as we also define one thing we define, which I have forgotten to write it here, is the correlation between v, omega, and r, and that was v equal to omega r. So velocity and angular velocity were related like this. So if you write v as omega r, then alpha is also r d omega by dt, because r ka magnitude is constant. And what is d omega by dt? D omega by dt is nothing but alpha. So tangential acceleration can be seen as dv by dt. It can also be seen as alpha into r, right? Then came the centripetal acceleration, which is omega into v, which came out to be v square by r, or omega square r. This is also omega into v. Directions are very important, guys. Centripetal or radial acceleration. Okay, this is also called as radial acceleration. Okay, good enough. Hope everybody remembers studying this with me last time. Let's see if you can solve a series of questions before we move to something in the discussion of dynamics. We have studied kinematics of circular motion, kinematics when we don't talk about the reason behind the motion, and today we'll speak about the reason behind the motion. I gave you a basic idea of that also last time, but we'll explain and we'll understand it in detail today. Okay, so everybody, question in front of you: what is the angular velocity in radians per second of a flywheel or simply a wheel or ceiling fan making 300 revolutions per minute? RPM means what? This means revolution per minute. It's a standard way of representing revolutions per minute. You will only write it in small short form as RPM. I will give you guys 60 seconds, and your time starts in 3, 2, and 1. You have to convert RPM into you have to convert revolutions per minute into radians per second. So you have to think on the lines that in one revolution, how much angle is covered? In one revolution, what is the magnitude of the angle covered? So you have to accordingly convert it into radians per second. Let's see how many of you guys are able to do this. Last 15 seconds, everyone. And the time is up. Okay, so a decent number of people were able to do this, but I was actually expecting better. So guys, omega, which is 300 revolutions per minute. Okay, good. So what is the angle that you cover in one revolution? You will say 360 degree, but as I told you, degrees is not SI unit. So the angle that is covered in one rotation is 2 pi radians. Okay, and per minute. So in 1 minute, how many seconds are there? 60 seconds are there. So radians per second it becomes always. Whenever you have to convert RPM, you have to actually multiply by 2 pi by 60. This will convert into radian per second. So 300 into pi by 30 radian per second it becomes. This will cancel it 10 times. Very simply, answer comes out to be 10 pi radians per second. Hence the correct answer is option B. Okay guys, good, very nice. Next question: the ratio of angular speeds of the minute hand and the hour hand of your watch. I hope you have a wall clock in your house. You can take help from that also to think which one is the hour hand and which one is the second hand. Okay. So let me try to help you guys out here with the diagram here. Okay, people. Okay. So definitely time come. So this one is your minute hand, and this one is your hour hand. The question is asking you angular speed of minute hand to hour hand. That means omega 1 is to omega 2. Kitna hoga? Giving you all 45 seconds, and your time starts in 3, 2, and 1. The ratio here. That's why you have to just bring both of them in the same unit system. That's all. Okay, very nice. So you know that for a complete circle, the total angular displacement is 2 pi and the time taken is capital T. So let's talk about omega for the time which they take to cover the same angle. That means what? When I want to talk about their omegas, I will talk about the same angle. And when that same angle is covered, I can say it is 2 pi by T1 into 2 pi by T2 SA. This is how I will write it. Right, everyone? 2 pi gets cancelled. Basically, omega is inversely proportional to the time period. Last time हमने ये discuss भी किया था. So this is T2 by T1. Okay, so one is your minute hand. How much time your minute hand takes to complete one circle? Everyone, how much time your minute hand takes to complete one circle in the chat box? Either 60 seconds. Oh, excuse me. Minute hand, not the second hand. This person, this particular hand will take 60 seconds. I'm talking about the minute hand, which tells you 5 minutes, 10 minutes, 15 minutes. So it takes 1 hour to complete one circle. Okay, so T1 is 1 hour. Okay, and how much time your hour hand takes to complete one circle? 12 hours. 12 घंटे लगते हैं. Right? So what is the answer? 12 is to 1. समझ में आ गया? You can write it in minutes also. Convert it into minutes also, but answer will not change. Okay, cool. Simple it is. Yes. So correct answer is 12 is to 1. Next one, everybody. The angular velocity of a particle moving in a circle of radius 50 centimeters is increased in 5 minutes. So omega initial is 100 rpm, omega final is 400 rpm. The time in which the omega changes is 5 minutes. Question is asking you the tangential acceleration. Question is asking you about tangential acceleration, that too in meters per second square. How much is that going to be? Question has given you the value of radius as 50 centimeter. My only piece of advice to all of you guys, it's really a challenging question. Okay, the only piece of advice that I want to share with you all is that you work with SI unit system. Try to work with SI unit system. Try to think about what angular velocity will lead to, so that you can talk about the tangential acceleration. Okay, giving you all 90 seconds, and your time starts in 3, 2, and 1. Last 10 seconds, everyone. Tangential acceleration is alpha r. If you got alpha, you just have to multiply it with r. That's all. Let's see how many of you got this. Very good. So let's see how do we get it. See, first of all, we are sure that tangential acceleration either is dv by dt or is alpha into r. All right. And if I want to find out alpha, I'll have to find out the change in angular velocity upon change in time. So first thing first, angular velocity is given to me in revolutions per minute. So if I talk about delta omega, it is 400 minus 100 rpm divided by how much time? 5 minutes, right? So first of all, this is 300 rpm. So this is 300 into 2 pi divided by 60. In that first question only we saw this. So this is only delta omega. This is only delta omega, and the time is 5 into 60. 5 into 60 because it is 5 minutes. I converted it into seconds. Guys, is this clear to all of you? The bracket is delta omega. This is delta omega, and this is delta t. Okay, very nice. So you see what else we can do? We have to find out the value of AT. AT is going to be alpha r. So that is 300 into 2 pi divided by 5 into 60 into 60. 5 into 60 is 300, right? And r ka value is 50 centimeter, which is half a meter, right everyone? 50 centimeter is half a meter. So 5 into 60 cancels 300, 2 cancels with 2, I'm left with pi by 60. And that 2 meter per second square. That's our answer. Samajh gaye? Well done. So far, the leaderboard is this. Good. Keep it going. All the best. Awesome. So switching off the chat now, and let's start the session for today. Today we are going to speak about two things. First thing is actually a very small discussion, because we have kind of done this discussion in the previous class only, and that is uniform and non-uniform circular motion. In fact, if you remember, I gave you the full flow chart about it. We spoke about uniform motion, uniform circular motion, non-uniform circular motion, and in non-uniform circular motion there are two possibilities. One is accelerated circular motion, which is uniform, and the other one is non-uniformly accelerated circular motion. So we did this last time. I gave you a flow chart about this. I told you where to use calculus, where to use 3 equations of motion and all that, right? So same thing is the discussion here. When we speak about uniform circular motion, this is actually kinematics, nothing else. If this is uniform circular motion, the magnitude of the velocity will remain constant, but can I say that the direction is changing every instant? Which velocity? Whenever they say only velocity, they're talking about linear velocity. Remember that. Whenever word velocity comes, you have to understand it as linear velocity. If they specifically want to talk about omega, they will have to say it angular velocity. Remember this part. Okay. So when the body is performing circular motion, it's inevitable to not. Basically, it is inevitable. What? The change in direction. That will definitely happen. But magnitude, if it's constant, that simply says that your omega will be a constant. By the way, omega, the angular velocity vector, can I say is a constant? Angular velocity vector is a constant. Clear? Why? Because when I talk about the circle, the body is continues to move in the same sense, clockwise or anti-clockwise. Sabko direction to yaad hi hoga. Angular velocity ka direction is perpendicular to the plane by which rule? Can you tell me the rule? Which rule do we call it? By which we find it? Right hand thumb rule. So as long as the body continues, screw rule or right hand thumb rule, as long as the body continues to move in the same sense with the same speed, omega remains constant. Both with magnitude and direction. Omega ke upar vector sign banaya maine. I made the vector sign over omega. Okay, everyone? Yeah. Good, awesome. So in this case, can I say definitely your tangential acceleration will be 0? Why? Because v is the magnitude which is constant. The magnitude dv by dt, it is changing. So that's why this is coming out to be 0. Okay, everybody? Cool. And centripetal acceleration can never be 0. It is necessary. It is necessary. Centripetal acceleration is because of the change in direction only will be equal to v square by r. And if I have to find out angular displacement, just like displacement equal to velocity into time, angular displacement will be equal to angular velocity into time. Okay, good enough. Vishesh, you can ask me at the end of the class. I'll explain you once again. And by that time, I expect you to have a microphone. Vishesh Brahmavat. Okay, I'll explain you the question at the end of the class. But by that time, have a microphone. Okay. So this was uniform circular motion. What if you're speaking about non-uniform circular motion? Then there are two possibilities, but they are only talking about non-uniform circular motion, which basically means the magnitude is also changing. Direction to वैसे ही it has to change. Direction is inevitable. ये तो change होना ही होना है. The only thing this time we can say is that tangential acceleration becomes non-zero. That's the new thing here, right? So maybe the magnitude is increasing or decreasing. Maybe the speed is increasing or decreasing. Both are possible. Okay? Yeah. अरे यार मैंने सेंट्रीफ्यूगल फोर्स के बारे में बात ही नहीं की है और तुम मतलब घूम फिर के सेंट्रीफ्यूगल फोर्स पे आ जाते हो जैसे पूरी वजह पढ़ चुके हो पहले से. हाँ? अभी तक नाम भी लिया मैंने सेंट्रीफ्यूगल फोर्स का. हाँ, सेंट्रीफ्यूगल फोर्स. मैंने सेंट्रीफ्यूगल एक्सेलरेशन भी नहीं बताया, मैंने सेंट्रीफ्यूगल फोर्स भी नहीं बताया अभी तक. मैंने कुछ भी नहीं बताया. सेंट्रीफ्यूगल वर्ड के बारे में डिस्कशन नहीं किया अभी तक. ठीक है? स्विचिंग ऑफ द चैट सो दैट Be focused here. Okay, everyone. Anyway, so we have understood this part so far. Okay. हाँ मैंने बोला था सेंट्रीफ्यूगल कुछ होता है बताऊंगा उसके बारे में अभी कुछ नहीं बताया ठीक है चलो आंसर दिस क्वेश्चन क्विकली एंड देन आई विल स्पीक अबाउट सेंट्रीपिटल एंड सेंट्रीफ्यूगल तुम्हारे फेवरेट दोस्तों के बारे में बात करेंगे सो फॉर अ पार्टिकल इन अ नॉन यूनिफॉर्मली एक्सेलरेटेड सर्कुलर मोशन नॉन यूनिफॉर्म accelerated motion second category there are four options which say that in non uniformly accelerated circular motion the velocity is radial acceleration is transverse this word transverse has to be seen as tangential so it says that in a non uniformly accelerated motion the velocity is radial acceleration is tangential only right second option says velocity is tangential acceleration is only radial third option says velocity is radial acceleration has both radial and transverse component fourth option says that velocity is tangential and acceleration has both radial and tangential components giving you all 30 seconds to ponder and answer and your time starts in 3 2 and 1 Are we done? Okay, very nice. So, oh my god. If it is non-uniform accelerated circular motion, that means the linear speed is not constant. If linear speed is not constant, definitely tangential acceleration is not zero, right? Why? Because tangential acceleration is dv by dt, the rate of change of speed. And if speed is not constant, definitely it is changing, so tangential acceleration is definitely existing. Centripetal acceleration has to be always non-zero for circular motion. This is always true whenever a body is moving in a circular path. So if we look at a circle where the body is moving, definitely the velocity has to be tangential. Velocity can never be in radial direction. Velocity is in this direction. And if we speak about tangential acceleration, it is there because velocity magnitude is changing and radial acceleration is also there. So clearly, option D, velocity is transverse, which is tangential. Acceleration has both radial and transverse components. Plus one if you understand. In the chat box. बहुत बढ़िया अब जो मैं समझाने जा रहा हूं what I'm going to explain you guys बहुत ध्यान से सुनना next 10 minutes are out of the discussion part maybe the discussion which is about to follow may not cover that part so I'm going to give you an understanding which you have to listen to very carefully ठीक है I will clarify every doubt that you guys are having let me just talk for next 10 minutes you will have all your doubts about centripetal centrifugal tangential and all those forces clear ठीक है कुछ बोल रहे हो you are saying something okay good okay so switching off the chat expecting you people to focus on the screen we are about to speak about centripetal and centrifugal force before the slides come I will tell you everything about them then we'll just go through the slides so everybody when we are talking about a circular motion let's first think from common sense point of view forget about knowing about all these vectors calculus and all those things let's speak from logical standpoint so when the body is moving in a circular path as I said either the body can go anti-clockwise or the body can go clockwise any of the possibilities we can take so I've taken this possibility right everyone so when this is the situation when the body is moving this is angular velocity if you will use right hand thumb rule the thumb is pointing towards you if you will curl your fingers in anti-clockwise sense the angular velocity ka direction displacement ka direction angular displacement theta and omega ka direction is coming towards you okay so everyone if I consider that omega is constant the direction of omega is definitely coming out of the plane that is the direction of omega and that is also the direction of theta okay so theta is always increasing when the body is moving okay so when the body is moving its angular displacement is increasing and the direction is towards you so if you look at its velocity vector the linear velocity whenever you say velocity it obviously means the linear velocity so this is the direction of its velocity so you are saying that omega is constant if omega is constant then v which is equal to omega r definitely your v is also constant because omega is constant radius ka magnitude is anyway not changing so v is constant that simply means what the speed is constant if speed is constant can I say that if the body after some time the direction changes inevitable the direction has to change all the time so after some time the body will reach here with the same speed after some time the body will reach here with the same speed after some time the body will reach here again with the same speed because omega is constant okay the first possibility right everyone so the question that comes in my mind as the person who's studying this motion is so the body is changing body's speed is not changing okay that makes sense so it sounds like something is uniform okay so from my understanding of uniform motion the body speed remains same then acceleration is zero okay makes sense the speed is constant so the acceleration is zero but is acceleration defined only for speed linear acceleration is it only defined for speed in fact linear acceleration is not defined for speed it is defined for velocity right everyone and velocity is not only magnitude it is not only speed it has direction also so let me look at the direction of speed or rather the velocity is that also constant definitely not I can see that as the body is moving body speed may be constant as per this speed is constant but the direction of the body is continuously changing and if direction changes okay direction always changes here so can I say that definitely there is an acceleration which is non-zero definitely there is acceleration in the body now my only question is how do I make sure that the speed does not change but the direction changes how do I bring an acceleration which can change the direction but does not change the magnitude of the speed so think about that force which will only try to change the direction will not try to change the magnitude of speed and now you have studied work per energy you know that if you want any object to change its speed the work done on the body is equal to the change in kinetic energy so if the speed will change kinetic energy will change if the speed is not changing right if the speed is not changing then the change in kinetic energy is zero very important point the speed of the body is constant in the uniform circular motion what we are studying right now is UCM uniform circular motion it is right what have I spoken so far Speed is constant, velocity is not. Direction is changing. Hence, there is an acceleration. But that acceleration has to be provided by a force which is only changing the direction. And in that process, the kinetic energy of the body should not change. That change should be zero. And if kinetic energy change is supposed to be zero, then work done has to be zero. When do I say work done by a force is zero? When it acts at an angle of 90 degree with the direction of displacement, with the direction of velocity. And that is why, my dear students, the force which is acting on your body in uniform circular motion will always act perpendicular to the direction of the velocity. And now you figure out what will you call this force. Its direction, you will see, is always and always perpendicular to the velocity. And by the looks of it, you can see that the force is acting towards the center of the circle. And that is why the force is called centripetal force. This force always acts at an angle of 90 degree with the velocity. Means what? This velocity of the object will always be tangential and this force will always be radial. Okay, everyone? So what will I call this acceleration? We will call this acceleration as centripetal acceleration. Okay, everyone? So this is nothing but centripetal acceleration. Its magnitude is v square by r. So can I say that the force which is going to bring this acceleration will also be given the similar name called as centripetal force? So this is mass into centripetal acceleration. Means what? It is nothing but the unbalanced force. It is an unbalanced force. If it would be a balanced force, then the body's velocity must have been constant. Velocity is not constant, only speed is constant, right? So that is why it is an unbalanced force which is equal to mass into acceleration, and that is mv square by r or m omega square r. What is the situation? This is the situation which we call as uniform circular motion or UCM. Only one force. Only and only one force. And very important point I have written here. Actually, this entire slide is very important. The work done by the centripetal force is always zero. That means what? It will neither increase nor decrease the kinetic energy of the body. Let me make it relatable. You know that all the satellites, including Moon, are revolving around Earth. Man-made satellites as well as the natural satellite Moon, revolving around Earth. But they neither speed up, they nor slow down. They always take 24 hours to complete the circle, especially the geostationary one, right? So that 24 hours always comes out to be a constant time, which results in constant omega, and that is because the force which is acting between the Moon, imagine here you have Moon, and imagine here you have Earth. The force which is acting between Moon and Earth is behaving as centripetal force, right? So that force can neither increase nor decrease the angular velocity of the body. Okay? Are you kidding me? Are you kidding me? Yes, you are. I just gave a monologue of 10 minutes, and you are asking me, sir, please repeat the entire slide. Harshita, क्या नहीं समझा वो बताओ तो फिर भी समझा सकता हूँ. क्या तुम कल के लेक्चर में थी, परसों के लेक्चर में? नहीं थी. थी ना? Exactly. It is not a complete blank thing for you. जो चीजें यहाँ लिखी हुई हैं, absolutely Greek and Latin तो है नहीं तुम्हारे लिए. तो क्या नहीं समझ में आ रहा है वो तुम बोलो, या मैं expect करता हूँ कि you will watch the replay of this part to understand everything one by one. Okay? Cool. Okay. Okay, guys. I hope it's not the case with everyone. Everyone has gone through the slide with me. Step by step, I have explained everything. So this is the first case where the body is moving with constant angular speed, and that is why only one force is acting on the body. Okay. Where is the observer? The last part. Where is your observer? The observer is out of this entire circle. That means right now you and me are the observers. We are looking at the situation from the top. We are looking at it from the top. We are neither Earth, we are nor on Moon. ना तो हम Earth पे हैं इस situation के according, ना हम Moon पे हैं according to this. ये मत बोलना कि हम Earth पे तो हैं. तो अभी for this example, we are not in this body. Okay, everyone? या ऐसा सोचो. If this is the Bohr's atomic model, this is electron and this is your nucleus. You are neither electron, you are non-nucleus. Okay, so you are looking at it from inertial or non-inertial frame of reference. थोड़ी देर बाद पूछूंगा, सोच लेना तब तक. Okay, so this was uniform circular motion. Let's talk about non-uniform circular motion and the forces which will act on the body. Okay, so people, let's talk about non-uniform circular motion. So when we speak about non-uniform circular motion, I hope you will understand NUCM means non-uniform circular motion. This time your omega is not constant, and if omega is not constant, magnitude or magnetic direction also, any of this thing. So if omega changes, this will change the velocity. That means what? This time the speed will also change, which simply means omega ka magnitude is changing. And if that happens, this time the speed of the body will also change. If speed changes, see, direction is any which way inevitable. Centripetal acceleration is already there, which is v square by r. It is already there. But now another type of acceleration will come into picture, because when we look at the linear velocity of the body, look at the magnitude of the green vector that I'm drawing, guys. Look at the length of the vector that I'm drawing. Okay, try to focus on the length of the green vector that I'm drawing. I hope you guys are following what I'm trying to do. From point A to B to C to D to E. You can see that VA is less than VB, is less than VC, is less than VD, is less than VE. That means as I'm moving in this anti-clockwise circle, the body's speed is continuously increasing. Right, everyone? So can I say that there has to be a force along with that centripetal force which was acting on the body? There is a centripetal force which is definitely acting on the body. It also requires another force in order to increase its speed, right? And that is the force which is acting in the tangential direction on the body. And that is the force which is resulting in the tangential acceleration, which we say is rate of change of speed, or is also given by alpha r, right? So what is your tangential force? Tangential force Ft is basically mass into tangential acceleration, and that is m into dv by dt, or you can also write it as m alpha r, anything, whichever information is given to you. The point is the angle between tangential acceleration and velocity, okay, angle between Ft and v can be 0 degree or 180 degree only. Why? Because both are acting in the tangential direction. So there are only two possibilities. One, if you try to increase the speed, the tangential acceleration will make 0 degree angle. It will act in the direction of velocity, right? You will basically try to push the body in the same direction. If you want the body to slow down, if you want the body to retard, the force has to act opposite to the direction of velocity. That is going to be the angle that is 180 degree. Okay, everyone? And definitely the work which will be done by the tangential force will be non-zero. The work done is definitely not going to be zero, because that is acting at an angle of 0 or 180 degree. Okay? And we are still watching this everything from outside. We are still watching everything from outside. So guys, which frame of reference we are? Inertial or non-inertial? Which frame of reference we are? We are inertial frame of reference because we are watching it from outside. There is acceleration in the system, but we are not present in it, right? Awesome. But if we are the person who is in this body which is moving in the circle, if we are present in this body which is moving in the circle, imagine a car which is taking a turn on the road. Imagine a car which is taking a turn on the road. Then you are in the car. Now imagine this. Try to visualize this. If you are in the bus or in the car which is taking the turn, you never stay. You never stay like vertical. You actually go little. You actually are pushed like this. Happens with us. You are pushed. If you are holding something, you will be pushed opposite to the imaginary center. That means what? If this is that car which is taking this turn, this is car ka velocity, and you are sitting here, and this is the center. So will you be pushed to the right or to the left? ध्यान से सोच के बताना. You will be pushed to the right. You will experience a push to the right. This is the direction in which you will be pushed, right, everyone? But you are still moving in the circle with the car. So definitely there is a force which is making you take this turn. So this force is your centripetal force, and this force is the pseudo force. Are you getting it, everyone? याद आ रहा है? कुछ याद आ रहा है? Pseudo force, always acting opposite to the direction of acceleration. Always acting opposite to the direction of acceleration is what we call as the pseudo force. और दोस्तों, बहनों, भाइयों, this pseudo force is called centrifugal force. तुम जो दिन रात इसके गाने गा रहे थे अब तक, the understanding of that is this. So centrifugal force is actually not every time talked about. It is only talked about when you are in the system, when you are in the non-inertial frame of reference. Am I clear? क्या मेरी बात समझ में आई? Only because pseudo force is centrifugal force is a pseudo force, and I hope you people remember our discussion of pseudo force. It only comes into existence when we are in the system, when we are present in the system which is accelerating. Okay, it's a false force, and it is always opposite to the direction of centripetal force. It will always try to take you away from the center. Because of that only you experience this push. मैं इसका सबसे beautiful example देता हूँ तुम्हें. Chat box पे एक भी शब्द मत लिखो, मैं तुम्हें बहुत beautiful example देने वाला हूँ. Stop writing anything in the chat box. I'm going to give you the most beautiful example of centrifugal force, and you will never forget about it. My guarantee. Stop writing anything. Thank you. कुछ भी मत बताना, मैं सब तुम्हें explain करूँगा, फिर बात करेंगे. आज today after the class, just look at the dryer of your washing machine. सिर्फ washing machine को जाके एक बार देखना, अंदर open करके. You will find there are small holes in it. There are small holes in it. Whatever type of washing machine it is, automatic or semi-automatic, doesn't matter. Why those holes are there? Because when your clothes are spinned inside it, when the washing machine spins, don't write anything. When the washing machine is spinning, all the clothes will go and stick to the wall. Okay, because of the centrifugal force, obviously. But when the clothes are sticking to the wall, they are not able to pass through that hole. Our objective is actually to dry the clothes. What do we understand by drying the clothes? Absence of water is drying the clothes. Absence of water is drying the clothes. So your clothes do not pass through the hole, but your water droplets still experiencing the centrifugal force. They just go out of those holes. And that is why your clothes feel relatively drier. Not 100% dry, but relatively drier. आया समझ में? Why that happens? Because your water droplets are present in the non-inertial frame of reference. Why? Because they are present in the thing which is accelerating. Clothes, if you will make bigger holes, they will also pass through the holes. Okay, if your clothes are small pieces, they will also pass through those holes because of the centrifugal force. Another example, especially people from north side of the country will relate to it more. कभी घर में लस्सी बनते हुए देखिए या बाहर, Punjabis in the house, लस्सी, buttermilk. Okay, there is one kitchen device which is taken in the hand and it is rolled like this. It's rolled like this. Churning, exactly. Blender, exactly, is what we call it. So when lassi is made, you will find the butter comes on the surface of it or on the edges of it. When the lassi is made, by blending it, the white butter comes on the edges of the container. Why that happens? Because of this, the process itself is called centrifugation. The name of the process is called centrifugation. So when you do this, butter particles, they experience centrifugal force and they come to the walls of the container. Okay? Feel again? That's what is the situation and understanding of centrifugal force. अच्छा, एक और चीज, अगर if you guys like to go on those rides, एक वो राइड होती है ना जो बोट वाली राइड होती है, it's like that. ऐसा वाला राइड होता है एसएल वर्ल्ड और बड़े-बड़े फेयर्स में. Yeah, those rides are there. Dragon wala ride, exactly. When the dragon ride comes down and comes to the bottom of it, when you are here in that dragon ride, you feel like your stomach is getting empty. It's because you're feeling a centrifugal force outside. Your body is experiencing a centrifugal force in this side. So you feel like you're actually sticking more and more to the boat. And I'm a very weak-hearted person, so I have taken that ride only once in my life. Never after that. अब अपने बेबी के वो मत सुनाने लग जाना मुझे किससे. ठीक है, समझ गए? फील आ गई पूरी? सर बट फॉर द रीजन फॉल्स फोर्स एक्ट्स अपोजिट. मैं बता तो चुका हूँ, ये सूडो फोर्स में बता दिया था मैंने विहान. एंड में और पूछ लेना, फिर से बता देंगे. सो नो सूडो टू टेंजेंशियल एक्सेलरेशन. प्रैक्टिकली मैंने कुछ सोचा इस बारे में. अगर उस डायरेक्शन में फोर्स है तो उसका सूडो फोर्स इस डायरेक्शन में भी लगेगा, ऐसा बोल सकते हैं क्या? I will find out this one. That's a real good question. I will need time to think about it. ठीक है, I'll time to think about it. ठीक है. Somebody has asked me कि सर centripetal force के opposite तो centrifugal force है, pseudo force है. But अगर tangential acceleration है, tangential force है, तो उसके against भी pseudo force होगा क्या? Okay. So I will think about it. I will let you guys know next time. थोड़ा सा सोचना पड़ेगा इस बारे में. ठीक. तो चलो जल्दी स्लाइड्स देखते हैं. Yes. So now we already know about all these things. Nikita, friction is just a force. Friction is just a real force. Okay. Like if in this example we speak about, then the body is already in air, so there is no question of, as in it is in vacuum. We are talking about this in vacuum, so there is no friction at all. But if you are talking about a car which is taking a turn, we'll see that there is friction acting on the car. Okay, so definitely the friction will come into picture when it can come into picture. Okay, so guys, let's speak about the dynamics once again as per the slides. So we have talked about the centripetal force. Why it comes into picture? Remember, centripetal force is an unbalanced net force, and that is why it is mass into acceleration. Okay, and what causes this force? What is the cause of this force? It is the change of direction. Change of direction of body, or I should rather say, this force is the reason for change of direction. Okay, like this example is giving you that the tension force is acting as the centripetal force. I hope you people remember last time I told you that centripetal force is not a natural force, or rather it's not a fundamental force. Fundamental का मतलब होता है which are there in the universe, and as much as the universe that we as human beings understand, there are only three fundamental forces that we expect to find everywhere in this universe, all the planets, all the bodies, and those are your gravitational force, electromagnetic force, and nuclear forces. These are the forces which make the other forces, right? So electromagnetic forces are the one which eventually behave as tension, spring force, normal force. All these forces are basically your electromagnetic forces. Okay, everyone. So centripetal force is not a new force. Different forces in different situations will behave as centripetal force. Like if you have this stone whose mass is m, is moving with a velocity v, so this force of tension is behaving as centripetal force, right? If we speak about, say, Earth and Sun system or Moon and Earth system, the gravitational force behaves as mv square by r. This is the next example that you see. We are going to study this in the next class more in detail, that whenever a car or a bus takes a road and there is a turn which comes, so that turn is made possible because of the force of friction which acts between the tire and the road. So this is your force of friction. And you know that when you are actually thinking of the situation in a rainy day, or when there is some oil which is spilled on the road, then it will be much more difficult to take that turn. So here this force of friction will behave as mv square by r for the vehicle. Okay. Similarly, Bohr's atomic model, it's the force of attraction between electron and nucleus which behaves as the centripetal force. You know this in the atomic structure also. Good. Cool. So we'll speak about this in gravitation, and we'll speak about this friction example in the next class. The entire section will have a lot of time dedicated to this. Cool. Awesome. And before I solve the questions, let me just show you the centrifugal force part also. So centrifugal force is often referred to as the equal and opposite reaction of centripetal force, and this is the myth. Now we understand the myth. Okay, centrifugal force is not the reaction force. Remember that centrifugal force is not the reaction force. It is the pseudo force. Okay, so whenever, say, we take a bucket of water and if we rotate that bucket in the horizontal circle, the water does not come out because it experiences a pseudo force. But practically, it is the force provided by the container which is keeping it in the circle. Because of that only, it does not come out. So remember that centrifugal force is a pseudo force. It comes into picture when you see the situation from a non-inertial frame of reference. Please remember that, everyone. But yes, magnitude-wise, your centrifugal force is equal to mv square by r. Means it is equal to the centripetal force in magnitude. Why? Because when you are in that car which is taking the turn, you are experiencing this, this push on the other side. But when you say you have covered all the glasses of the car, you will still be sitting in the car only. That means for you, the car is not moving. For car, you are not moving. That means you are at rest, and you are only at rest. Just like in the lift, when you are in lift and the lift was going up, you experienced the increased weight because of the pseudo force. This time you are at rest because your centripetal force is being balanced by centrifugal force, and you are inside the car. So that is why centrifugal force has same magnitude as that of centripetal force. Remember that. Okay, everyone. So this is centrifugal force. Okay. Now, shall we go to problem solving? Only problem solving left for today now. We were supposed to talk about all these things. Okay. So I'll first give you an example, then we'll go to problem solving. Right. Like this one. A ball is going around in a circle attached to the string. If the string breaks at an instant, which is shown here, which of the three paths do you think will represent the motion of the body after the string is broken? Let's see. Okay, majority people are going with B, and that is the correct answer. Body will go towards that because of inertia. The body is in inertia. An object in the motion wants to remain in motion at constant speed in a straight line. So if the unbalanced centripetal force is removed, the object will continue in the straight path. Right, everyone? When the force becomes zero, the body's velocity will become constant. So the body's constant velocity will take it to the straight line. Yeah, perfect. So फिर अब questions हैं quizzes के only. Now only quizzes for all of you. Are we ready? Okay. I don't know how many. बहुत सारे हैं questions तो बहुत सारे हैं. ठीक है. चलो. Yeah. A body of mass 5 kg, switching off the chat. A body of mass 5 kg is moving in a circle of radius 1 meter with an angular velocity of 5 radians per second. You just have to calculate the centripetal force. Giving you all 45 seconds. Take 1 minute. And your time to calculate centripetal force. चलो पहला question है इसलिए formula भी बता देता हूँ. mv square by r और m omega square r. Giving you 60 seconds. Time starts in 3, 2, and 1. Excuse me. So okay, everyone, the time is up. Good job. And let's see. So as the question has given me omega, I go with formula number 2. So centripetal force will be mass of the body, omega square, and radius already in SI unit. So this is 5 into 4, 20 Newton. That's the answer. It's very easy warm-up question for all of you. Let's move on to the next one. This one says that if the radius of curvature of the path of two particles of same masses are in the ratio 1:2. Okay, if the radius of curvature of the path of two particles of same masses are in the ratio 1:2, radius of curvature means what? Instead of talking about the entire circular path, say if the situation is talking about only a small portion of the circle, then for this small portion of the circle, if you trace out the radius, that radius is called radius of curvature. Means now entire circle is not there, only a curve is given. So this r basically is the radius of that circle, imaginary circle. So that radius for two path is 1:2, and the particles are of same mass, then in order to have the constant centripetal force, their velocity should be in the ratio. So basically, question is saying F1 is equal to F2, M1 is equal to M2. So what will you say the ratio of V1 is to V2 is going to be how much? Giving you 45 seconds now, and your time starts in 3, 2, and 1. Last 10 seconds now. Okay, and the time is up. Let's see. Okay. This was actually easy, honestly. Honestly, everyone, this was actually easy. So if both the forces are equal, we know that centripetal force is mv squared by r. And question has only spoken about the velocity. So will I consider it angular velocity or linear velocity? I told you, if only velocity word is there, then you will understand it to be the linear velocity. That means mv squared by r. So if f1 is equal to f2, then I will say mv1 square by r1 is equal to mv2 square by r2. Why m? Because both of them have the same mass as well. So m gets cancelled. We can say that v1 by v2 ka square is equal to r1 by r2. So v1 by v2 will be under root of r1 by r2. What is radius ka ratio? 1:2, and that's what is your answer also. 1:2 is the answer. Okay. You don't need to have this. This may confuse you. Okay. So that's our answer, everyone. 1:2. Let's go to the next one. If you are listening to my monologue very clearly, you will be able to answer it very, very, very easily. It says that a sphere of mass m is tied to the end of a string of length L, and it is rotated through the other end along a horizontal circle. So basically, you have a horizontal circular motion because of a thread which is connecting a sphere. Okay, so we have a sphere which is connected to a thread, and this thread has a tension force, has a radius r, and the length of string, the radius is actually L. Okay, the radius is actually the length of the string. So question says that if the speed of the rotation of this sphere is v, then the work done in the full horizontal circle by the centripetal force will be how much? Giving you 45 seconds to think about it. Find out the work done by the centripetal force, and your time starts in 3, 2, and 1. Last 10 seconds now. Okay. Still better. The correct answer is 0. The correct answer is 0. Remember, the work done is 0 when it is uniform circular motion. And why? Because only force which is acting is centripetal force. By the way, here also the work done is going to be 0. But work done by tangential force is not 0. So work done by centripetal force will always be 0 because it is acting at an angle of 90 degrees. It's a very important concept to remember, everybody. This is actually not just a question, it is a concept. So it is something that I want you people to remember. Okay? Because centripetal force acts at 90 degree with velocity. And I should say because centripetal force always acts at 90 degree with velocity. Hence, it doesn't do any work, or it doesn't deliver any power. Remember this for your life. Always remember this part. As long as you are preparing for JEE, at least till then, I want you to remember this. Because centripetal force always at 90 degree in the direction of motion, work done will always come out to be 0. That's why. Okay. Power is centripetal force into velocity into cos of 90 degree, 0. So remember. Okay. So next one. This question says that a ball of mass 0.25 kg is attached to the end of a string of length 1.96 meters, is moving in a horizontal circle. The string will break. See, abhi pura discussion jo hai so far. In fact, in the next class also will be only about horizontal circle. The last session of circular motion will be about vertical circular motion. So as of now, everything is moving in horizontal circle. So basically, it says that the body has a mass m, which is 0.25 kg. Its radius is 1.96 meters. The string will break if the tension is more than 25. So this is the maximum tension which you can deliver to the string. So what is the maximum speed with which the ball can be moved? Only thing that I can say, that when the string is moved in the circle, it's the force of tension which behaves as the centripetal force. Okay, guys. So I'm giving you all 1 minute to find out the value of the maximum speed with which you can make the body move, and your time to do that starts in 3, 2, and 1. Okay. As long as you are watching it from outside, only centripetal force is to be taken into account. Half time gone. $15 seconds approaching. Okay. And the time is up. That's nice. Okay. So what I was supposed to do in this, that tension force is behaving as mv square by r. Mass, you can't change. Radius, you're not changing. So if you want to maximize tension, the speed will also become maximized, or vice versa. If you want to increase the speed, tension has to be increased. So in order to find out V max, T should also be maximum, and that is given to us as 25. Mass of the body is 0.25. This is V square, or V max ka square, divided by 1.96 the radius. So V max square will be 25 into 1.96 divided by 0.25. So this can be seen as 25 into 196 upon 25. 25 cancels. 196 is the square root of 14. So V max comes out to be 14 meter per second. Okay. Yeah, so that's the answer. Now this one, it says that थोड़ा सा chemistry से pick up किया हुआ language है. This says that we have a proton of mass 1.6 into 10 to the power minus 27 kgs. It goes around in a circular orbit of radius 0.1 meters under the centripetal force, which is also given. Then the frequency of revolution of the proton is how much? You have been asked the frequency. You're not being asked omega. You're being asked frequency. Okay, so frequency is basically 1 upon time period. Only itna I will tell you. I will not say anything else. Okay, and I'm going to give you guys full 2 minutes to answer this. You have to find out frequency. 2 minutes are there in front of you. Let's see how do you solve this. How do you figure it out? For the first time today, I'm throwing you in front of a situation which I'm expecting some of you will find challenging. So the time for 2 minutes starts in 3, 2, and 1. Forty-five seconds remaining. Okay, and the time is up. क्या बात है? Still, decent number of people could get this. So first of all, the concept. See guys, frequency is 1 upon time period. But if you multiply both sides by 2 pi, then you are basically talking about omega, right? So if I get omega, I can find out the value of frequency as omega upon 2 pi. We talked about the frequency last time also. Okay, so how do I get omega? We know that centripetal force, which is mv square by r. Most of the time people remember only this formula. Remember there is another formula, which is m omega square r. So from here you'll be able to find out omega also. So guys, omega will be equal to f by mr in under root. And if I want to find out frequency, which is omega upon 2 pi, then I'll be calculating 1 upon 2 pi under root of f by mr. Okay, so let's solve it on the next page here. So frequency 1 upon 2 pi under root of force, that is 4 into 10 to the power minus 13 divided by mr, right? So mass is 1.6 into 10 to the power minus 27. So I'm directly writing it as 16 into 10 to the power minus 28. This 27 I'm making it 28 so that I can cancel 16 by 4. And the radius is 0.1, so 10 to the power minus 1 it is. Good. So this cancels it 4 times, 1 by 4, 2 will come out. So 1 upon 2 pi into 1 upon 2. And what I'm left with inside is 10 to the power minus 13 into 10 to the power plus 28 into 10 to the power 1. That means it is 10 to the power 12, 10 to the power 28. That means 8 and 8, 16. So 10 to the power 16 in under root. 10 to the power 16 in under root, which is 10 to the power 16 by 2. So this is 10 to the power 8. ये वाला part समझ में आता है सबको? 10 to the power 8 वाला. Everyone, you got this? Okay, thank you. Stop spamming Shyam Sundar. Okay, yes, thank you. So everyone, what I have is 1 upon 4 pi into 10 to the power 8. So yeah, 10 to the power 8 तो हर एक में ही है. So there is nothing that I'm benefiting out of the options. 1 upon 4 is 0.25 by pi. उसको nearly 3 लिख देते हैं. Nearly 3 I'm writing because options have a good spacing. Into 10 to the power 8. So if this would have been 24, the value would have been 8 directly. So this is 0.08 into 10 to the power 8 cycles per second. Get it? Maths, only calculations. Once you have got to the formula, after that only calculations. Sir, can we use the formula speed equal to frequency into velocity? And speed equal to frequency into velocity. Speed equal to frequency into velocity. ये तो डायमेंशनली करेक्ट नहीं है. सर थोड़ा और टाइम होता तो हो जाता. आई थिंक 2 मिनट से ज्यादा टाइम था थोड़ा सा तो. स्पीड इज इक्वल टू फ्रीक्वेंसी इनटू वेलोसिटी. मतलब ये कौन से डायमेंशन में करेक्ट फॉर्मूला है? हाँ तो लैम्डा किधर है क्वेश्चन में? अरे सी इक्वल टू एफ वी नाम का कोई फॉर्मूला नहीं है मित्रों. हाँ 8 बजे की न्यूज कम देखा करो. सर शुड आई वॉच रिप्ले? थोड़ी चीजें समझ नहीं आ रही. सर शुड आई ईट फूड बिकॉज़ आजकल मुझे भूख लग रही है. हाँ शुड आई ईट फूड इफ आई एम हंग्री? हाँ एग्जैक्टली. कुछ लोगों को शायद ये फॉर्मूला याद आ रहा है, सी इक्वल टू न्यू लैम्डा या एफ लैम्डा. ये फॉर्मूला याद आ रहा है क्या? ये है फॉर्मूला. अच्छा फॉर्मूला है. अच्छा फॉर्मूला, बहुत सुंदर है. ब्यूटीफुल ब्यूटीफुल फॉर्मूला. आएगा कभी काम आएगा, पर अभी काम नहीं आएगा. ठीक है. थैंक गॉड किसी ने ये नहीं बोला कि सर स्पीड इज इक्वल टू डिस्टेंस इनटू टाइम भी होता है। सर v इक्वल टू u प्लस at भी होता है ना। तो बहुत काम आएगा ये फॉर्मूला आगे जाके। चलो भाई, स्विचिंग ऑफ द चैट वंस अगेन, स्टॉप राइटिंग थिंग्स ऑन द डाउट पैनल, क्योंकि मैंने बोला था ना बहुत सारे क्वेश्चंस हैं तो अभी करने हैं बहुत सारे क्वेश्चंस। अभी फिलहाल के लिए लीडर बोर्ड का स्टेटस ये है, आफ्टर एटलीस्ट 9 क्वेश्चंस, एटलीस्ट 9 क्वेश्चंस तो हो गए। और अभी कितने क्वेश्चंस और हैं? 1 2 3 4 5 6 7 मोर क्वेश्चंस आर देयर, 7 क्वेश्चंस मोर। तो अगर अभी तक तुम लीडर बोर्ड में नहीं हो, यू कैन स्टिल मेक एन एंट्री हियर। ओके कूल, ऑल द बेस्ट एवरीवन। टेकिंग यू टू क्वेश्चंस व्हिच यू विल फाइंड लिटिल फेमिलियर एटलीस्ट विद द फॉन्ट्स। कहां के सवाल है ये? दीस आर क्वेश्चंस फ्रॉम तत्व के सवाल हैं ये, ठीक है। हाँ दिलराज, डाउट्स पूछ सकते हो बच्चा, नॉट अ प्रॉब्लम, ठीक है। यू कैन डेफिनेटली, यू शुड डेफिनेटली वॉच द रिप्ले आल्सो, बट यू कैन आस्क मी डाउट्स एट द एंड। चलो तो फटाफट आगे जाएंगे। रीड द क्वेश्चन एवरीवन, आई एम सेटिंग अप द क्विज एंड ठीक है। Two cars of masses m1 and m2 are moving along the circular path of radius r1 and r2. They take one round in the same time. They take same time to complete the circle. ठीक है। The ratio of angular velocity of two cars will be how much? Omega 1 is to omega 2 कितना होगा? अच्छा एक और बात बता देता हूँ, क्लास में बहुत स्मार्ट बच्चे हैं, many smart students are there, future engineers are there. So definitely the moment Suri sir has said the questions are from Tattva, many people might have opened up the Tattva also by now and started looking for the question already, and then directly jumping to the exercise answer key. Right? Definitely you can get points by directly answering it, and I will obviously not be able to find out whether you are doing that or not. But remember, you will be able to do it today, but you will not be able to do it in any of the tests. So what are you here for? You should remember that. Are you here to score marks to be in the leaderboard, or are you here to actually learn and eventually score marks in your actual examination? Only that's what I say. Okay. So question in front of you, giving you only 45 seconds from now, and the time starts in 3, 2, and 1. Questions are actually not very difficult, so I'm expecting you people to be able to get this, even by your own understanding. Should be able to do this very easily. The time taken to complete one circle is same, so the ratio of omegas will be how much? Quickly, doesn't even require 10 seconds to answer, by the way. Okay, time's up. Let's see. Surprising. Question has said that the value of t1 is equal to t2. The time taken to complete one circle is called time period. And my dear students, omega is 2 pi by t. So 2 pi by t1 is to 2 pi by t2, like this. So ratio is t2 is to t1, which is basically 1, because they are equal. So that's why the correct answer is option C. Okay, let's take you to the next question. Question says, in the circular motion, the centripetal acceleration is given by which of these formulas? Formulas are there in front of you. Setting up the quiz and giving you only 30 seconds, and your time starts in 3, 2, and 1. Obviously, symbols have the usual meaning. Last 5 seconds, everyone. Expecting a great response in this one. Let's see. Oh my god. यार देखो, ये तो आंसर ही नहीं हो सकते, because acceleration multiplied with r, acceleration multiplied with v will not give me an acceleration. So definitely answer cannot be a and c. And omega r we already know is velocity. This is v. So omega into v is the only thing which is acceleration. And if you will go to the previous session notes, you will find out that overall acceleration came out to be omega cross v plus alpha into r, or alpha cross r. So this one we defined as radial acceleration or centripetal acceleration. This one we defined as tangential acceleration. Okay, so answer came out to be option B. Now this one, it says that a particle moves in a circle of radius 25 centimeters at 2 revolutions per second. Omega is 2 revolutions per second. Okay, not per minute. RPM नहीं है, RPS given है. Question is asking you to find out the acceleration of the particle, and you have to obviously consider omega is constant. So find out the acceleration of the particle. Let me set up the quiz and giving you 60 seconds. Time starts in 3, 2, and 1. Again, does not require 60 seconds, but let's see. If you find it calculative, then you may require this much time. Okay, the time is up. Okay, everyone. So this was actually easy. We know that centripetal acceleration is the only acceleration when omega is constant, and that will be given by omega square r. So this is 2 square, sorry, my bad. Omega is revolutions per second. So 2 into 2 pi radian per second. So this is 4 pi radian per second. So this will become 4 pi car square into 25 centimeter converted into 100. So this is basically 1 by 4. So this is 16 by 4 pi square, or simply 4 pi square radian per second square. Already question told you to, sorry, meter per second square. Angular acceleration nahi hai, linear acceleration hai. So it is already given you it in meters per second square. That's why the answer comes out to be option C. Okay, got it? We converted revolutions per second into radians per second by multiplying it with 2 pi. So 2 into 2 pi gives me 4 pi value. Omega square r, 4 pi ka square multiplied by r. R is given in centimeters, so we converted into meters. 25 centimeters is 1 by 4th of a meter. So after that only maths. Next one, everybody. Read the options. Starts reading the question. I'm not going to read it for you. Read it. I am setting up the quiz. Okay. So guys, what happens to the centripetal acceleration of a revolving body if you double the orbital velocity? Sorry, if you double the orbital speed and half the angular velocity. That means if you make v as 2v and if you make omega as omega by 2, so how much will you find acceleration to be changing? Giving you guys 45 seconds. Time starts in 3, 2, and 1. If you are paying good attention to all the questions, you will actually solve it like this. Actually, there is nothing to solve. Okay. अगर ये सवाल याद है that centripetal acceleration is omega into v, so the answer very obviously it will remain unchanged. Why? Because a is omega into v. A dash omega is becoming omega by 2, v is becoming 2v, still comes out to be omega v, which is equal to a. Okay. Chalo, next one. It says that centrifugal force is considered as pseudo force. Free के marks है ये वाले question में. If you are listening to me carefully, should be able to answer it very quickly. And I will actually not give you much time for this. You have to look at the answers options. It says that which of these will be valid for pseudo force. Okay. An observer at the center of the circular motion when it is present will be able to. Then you have to consider centrifugal force in the situation. If the observer is outside, if the observer is moving with the particle which is experiencing this force, then last option is none of the above. Giving you 30 seconds and your time starts in 3, 2, and 1. Come on. Quick. Yes. I want majority answers to be right for this one at least. Okay, that's good. So, told you centrifugal force is only seen or brought into picture from a non-inertial frame. That's why. Okay, another one. Read the question. Question options in front of you. A body is moving with constant speed v in a circle of radius r. Its angular acceleration is going to be how much? Giving you 30 seconds and your time starts in 3, 2, and 1. All of these are good questions, conceptual questions. And this is the second last question, by the way. So everyone, v is constant. Obviously velocity constant नहीं हो सकती circular motion में. It's the speed which is constant. Hence omega is also constant. And if omega is constant, alpha, which is change in angular velocity per unit time, will be 0. Answer is option A. Right? Everyone. Now this one, the last question. It says that a particle is moving in a circle of radius 6 meter with uniform speed of 8 meters per second. The average acceleration when the particle completes one half of the revolution. That means the body is moving, and when it completes half the circle, what is its linear acceleration? Ka average value. So maybe the body has gone from A to B. Its speed is constant. Velocity definitely is not constant. You have to find out the value of acceleration, which is change in velocity upon change in time. That's what the question is asking from kinematics. Giving you people full 90 seconds and your time starts in 3. No, it will require you to take 2 minutes. You will require to find out the time period also. कितना time लगेगा ACB जाने में, that is also you will have to find out. Okay guys, you'll have to find that also. So you will have to find out this, you'll have to find out this also. Okay. How will you do that? The time period is 2 pi r by v. V speed. So t by 2, the time taken to go from A to B is t by 2. I have done such a question in the previous class. So pi r by v will give you the value of the time taken. Delta v is something that I'm relying on you, giving you 2 minutes and your time starts in 3, 2, and 1. Come on people. Concept, if you're good with concept, you'll be able to get this easily. Half time gone. Last 25 seconds. Last 10 seconds now. And the time is up. Okay, and oh my god. If you look at velocity at A, that is say positive velocity v, or you can call it v j cap also, right? If you look at velocity at B, you will say it is minus v j cap, right? So what is the change in velocity? It is final velocity minus initial velocity by common sense. Okay, so minus v j cap minus of v j cap, because you're subtracting this. So change in velocity vector comes out to be minus 2 v j cap, and the magnitude comes out to be 2v. correct? The magnitude of change comes out to be 2v. So if I want to find out the magnitude, I will be going in this by saying that acceleration is change in velocity upon change in time. So time is 2 pi r by v, change in velocity is 2v. So 2v upon 2 pi r by v. So 2 and 2 got cancelled. Sorry, pi r by v. Time is pi r by v, only half of the time. So this is 2v square by pi r. That's what is the acceleration. So 2 into speed, that is 8, into 8 divided by pi, the radius is 6. This cancels it 3 times. 8 is 64 by 3 pi meters per second square. That's the answer to the question. Okay, everyone? And the leaderboard in front of you guys. Kya baat hai? Very good, Harshita. Congratulations, a big congratulations to you. And Adish and Garv Goyal, top 3 people. Well done, everyone. Well done. Congratulations to each one of you. In fact, not just the people in the leaderboard, definitely everyone who tried their best. That's what matters in my class. Okay. We're moving the leaderboard in next 5 seconds. So please take a screenshot if you want to, or watch the replay to take the screenshot. 5, 4, 3, 2, 1. That's it. Okay. Good. So before I switch on the chat, this is officially the end of the class. Those students who want to exit the session, it is perfectly okay to exit the session. Class teachers, once you're done with explaining the doubts which are there in your domain, you can also exit the class. Okay. Now switching on the chat. Oof. No problem. Akash. What happened? Akash Krishnan. I'm not showing the leaderboard now. You can watch the replay later on for the leaderboard. I'm about to play that dholak or whatever random things that you guys like. बिल्कुल सर्कुलर मोशन के हर सेशन का रिप्ले जरूर देखना तुम्हें, ठीक है? मुझे बिल्कुल नहीं सुनाई देता है, मतलब मेरे एंड पे कोई आवाज नहीं आती है. ठीक है, अब जो इस चीज का वेट कर रहे थे दे कैन लीव. ठीक है, हाँ. साउंड्स अमेजिंग. ओके, मन को शांति मिलती है. ओके, अच्छी बात है. और बोलो. W2 3000. लॉन्गेस्ट क्विज एवर, ऐसा क्या? यस, इस चैप्टर का डाउट है तो पूछो, अगर प्रीवियस चैप्टर का डाउट है तो वेट फॉर द तत्व डिस्कशन टू हैपन. Wait for the tattoo sessions. You guys are having tattoo sessions now, right? So wait for them. Okay. So why the red lines along are in the center of direction? Eh? Why the red lines along are the center to direction? I'm not getting the question only. I didn't get your question, Lisa. Good evening. I didn't get your question. Yes. The slide of centripetal force. Just a second. The one which I made. This one. Yeah. Those are centripetal forces. Centripetal force. So last time when we found the acceleration came out to be omega cross v and alpha cross r. You remember this slide? When we found the direction of omega cross v, we got this direction along radial and this along tangential. That's why. So the direction of omega cross v is always towards the center when the body is moving like this. So that acceleration, come again? By the cross product to right hand thumb rule, yes. If you try to rotate omega in the direction of v, you will get the direction which is always towards the center in the body. That's why. Okay. Aman, I will unmute you. Vihan, your microphone is not working. Yes, Aman. Good evening. Tell me. थोड़ी देर रुकोगे, है ना? अकेडमी वाले कर देता हूँ पहले क्लियर, फिर Sudhir, any force which is mass into acceleration is an unbalanced force. Any force which you write as mass into acceleration is an unbalanced force. That's why. And centripetal force is mass into centripetal acceleration. That's why. Sir, क्या ये सही स्पीड है? मतलब Tonight, Shweta. Sir, exercise तत्व का बहुत टाइम ले रहा है, about 10-12 questions in 1 hour. क्या ये सही स्पीड है? एक्चुअली थोड़ा और बढ़ा सकते हो स्पीड को. सी मैं ऐसे देखता हूँ उसको कि अगर 1 घंटे में 60 मिनट्स हैं और मुझे हर क्वेश्चन को आइडियली 4 मिनट से ज्यादा नहीं लगना चाहिए. एक्सरसाइज 1 का एवरेज टाइम 4 मिनट भी पकड़ लेते हैं. वैसे तो 3 मिनट आइडियल टाइम पकड़ना चाहिए मुझे. सो 60/3 20 क्वेश्चन होने चाहिए, तो 15 से 20 क्वेश्चन आराम से बनने चाहिए. आई एम आंसरिंग समबडीज डाउट व्हिच हैज बीन आस्क्ड इन हिंदी. हर्षन, द डाउट वाज इफ आई एम एबल टू सॉल्व 12 क्वेश्चंस इन 1 hour is it a good speed? I said no, 15 to 20 questions per hour is a decent speed. Better than that is awesome. You should try to increase your speed of solving. Okay. Try to look back whether you have understood the concept properly or not. Okay. But if that speed is consistent, no, Pradipta, if that speed is consistent, 12. So look at it for next 2-3 more weeks. Try to take it from 12 to 14. Directly from 12, you will not be able to jump to 20 questions per hour. Okay. So is that good enough for face test? Yes, definitely. Lisa, exercise 1 and 2 are definitely good enough. In some questions we get stuck. Obviously, you are supposed to get stuck. So centripetal force depends on frame of reference. No, centripetal force is a fundamental force. It does not depend on frame of reference. Only centrifugal force depends. Bye, girl. Okay, Pradipta, you can do that. Not a problem. Vihan, not working. So I take a lot of time to solve exercise for the first time. 10 questions for more than 35 to 40 minutes. It eventually comes down to the same thing, Harshan. What Pradipta is saying. At that rate, you will actually be able to solve 15 questions per hour, which is actually not bad. सर पहले कॉन्सेप्ट पढ़ना चाहिए या फिर तत्व सॉल्विंग के साथ कॉन्सेप्ट देख कर. मैं पर्सनली रेकमेंड करूंगा तत्व सॉल्व करते जाना चाहिए, कॉन्सेप्ट देखते देखते. So one of series told that it depends, sir. Siddharth, I do not know who said so, but I'm giving you the answer. Centripetal force does not depend on the frame of reference. Sir, can you please try now? Yes, definitely. So time should be according to type of questions. Yes, Rajkumar. Hi, Vihan. Good evening. Bolo. Yes, you are. Come again? I remember. Now I kind of remember it now. Uh, तुम इसके लिए अनम्यूट करवा रहे थे? हाँ? ये आया मेरे दिमाग में। कहना क्या चाहते हो? सीधा-सीधा बोलो, स्ट्रेट फॉरवर्ड। मैं स्ट्रेट फॉरवर्ड बातें ज़्यादा अच्छे से समझता हूँ एंड आई डोंट माइंड। आज से 3 महीने पहले एग्ज़ैक्टली ऑन दिस डेट 11th ऑफ मई, नहीं 11th ऑफ मई नहीं हो सकता, 11th ऑफ जून। तो अप्रैल रहा होगा। हाँ, इनफैक्ट अप्रैल रहा होगा, अप्रैल रहा होगा। मई में तो आई वाज़ मीडियम टीचिंग। हाँ, 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 एग्ज़ैक्टली, एग्ज़ैक्टली याद आ गया मुझे। तो बेसिकली तुम फेसबुक मेमोरी की तरह बात कर रहे हो कि ऑन दिस डे दैट ईयर यू वर डूइंग दिस। ठीक है, और बोलो, कोई डाउट है? हाँ, क्या क्या था वो सवाल पूछो वापस? तो हमने जब भी पहली बार सुडोकोस का डिस्कशन किया था कौन से चैप्टर में, लॉज ऑफ मोशन में, तो हमने उसे एक्चुअली एक्सपीरियंशियली भी समझा था कि जब हम लिफ्ट में होते हैं और लिफ्ट ऊपर जाना शुरू करती है और एक्सेलरेट करती है तो सुडोकोस अपोजिट टू द डायरेक्शन ऑफ मोशन होता है, और जब लिफ्ट रिटार्ड करती है तो अलोंग द डायरेक्शन ऑफ मोशन होता है। ठीक है, यहाँ पे सेंट्रीपिटल फोर्स का डायरेक्शन इज ऑलवेज द सेम, दैट इज एक्टिंग टुवर्ड्स द सेंटर, तो उसके अपोजिट डायरेक्शन में ही सेंट्रीफ्यूगल फोर्स लगता है, विच इज सुडो फोर्स। सो सेंट्रीपिटल फोर्स विल ऑलवेज बी अपोजिट टू द डायरेक्शन ऑफ एक्सेलरेशन, वैसे याद रख सकते हो सेंट्रीफ्यूगल फोर्स। या सुडो फोर्स तो डेफिनेटली एग्जिस्ट कर सकता है इफ यू आर लुकिंग एट इट फ्रॉम नॉन इनर्शियल फ्रेम ऑफ रेफरेंस। मतलब अगर मान लो वो फोर्स इस बॉडी पे लग रहा है और मैं इमेजिन करूं यहाँ पे एंटमैन बैठा हुआ है, तो एंटमैन को सुडो फोर्स फील होगा। जैसे जैसे ऑब्जेक्ट मूव करने की कोशिश करेगा वैसे वैसे सुडो फोर्स फील होता जाएगा। मैं बनाती तो दिया हूँ, तुम्हें क्यों बनाने? बनाते जाओ, यहाँ से बनाते जाओ, जो जो चीजें मैं बताता जा रहा हूँ, ज्यादा थियरी है ही नहीं सर्कुलर मोशन में। और है ही नहीं, प्रॉब्लम सॉल्विंग पे जंप करो, अब तक ज्यादा कुछ पढ़ाया ही नहीं। अगर मैं थियरी के पॉइंट ऑफ व्यू से बोलूं तो सिर्फ इक्वेशंस ऑफ मोशन बताइए जो कि ऑलरेडी हम जानते थे। सिर्फ यहाँ पे अब v की जगह ओमेगा आ गया, डिस्प्लेसमेंट की जगह थीटा आ गया, एक्सेलरेशन की जगह अल्फा आ गया, और फिर कोरिलेशन आ गए कि v जो है वो इक्वल टू ओमेगा आर है, a जो है वो अल्फा आर है, at इज अल्फा, और एक ac और नया आ गया व्हिच इज v स्क्वायर बाय आर, दैट्स इट। और फिर अभी आज हमने फोर्सेस डिफाइन कर लिए जो कि एक्चुअली ac और at के साथ मास को मल्टीप्लाई करने से मिल जाते हैं, दैट्स ऑल। देखो 11th स्टैंडर्ड तक तो चलो ये फिर भी करना ठीक है जो तुम कर रहे हो ओवरऑल। 12th में जब आ जाओगे ना तो आई रेकमेंड डूइंग दिस ओनली ऑन शीट ऑफ पेपर, ओनली ऑन सिंगल शीट ऑफ पेपर। तुम अभी एक पेज पे, दूसरे पेज पे, तीसरे पेज, चौथे पेज पे जाते हो ना, इन योर जे एग्जामिनेशन यू विल गेट लिमिटेड नंबर ऑफ शीट्स। तो जितना छोटा लिखोगे उतना ज्यादा अच्छा, जितना छोटा और जितना लिमिटेड लिखोगे। तो जैसे मैंने क्यों बोला 12th में जाके, क्योंकि 11th में अभी भी हमारा थॉट प्रोसेस डेवलप ही हुआ है और ये सारी चीजें डेवलपमेंट का ही पार्ट है कि अभी अपनी गलतियां खुद से समझ में आने लगती हैं, और दीज आर बेसिकली प्रैक्टिकल नॉन एकेडमिक एरर्स, और आई शुड से नॉन एकेडमिक लर्निंग्स, है ना। कि अगर मैं क्वेश्चन नंबर नहीं लिखता हूं तो इससे एक डिसएडवांटेज है, तो कॉन्शियसली हर पेपर में मुझे ट्राई करना है कि मैं क्वेश्चन नंबर लिखूं, ताकि जब मैं उस क्वेश्चन पे दोबारा आऊं तो मुझे पता हो कि मैं क्या किया था उस क्वेश्चन में पहले थॉट प्रोसेस में। तो दैट्स व्हाट यू शुड कॉन्शियसली ट्राई। ठीक है, फिर धीरे 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 उसको नंबर ऑफ पेजेस कम करने की कोशिश करो जो तुम यूज करते हो व्हेन यू आर अटेम्प्टिंग अ पेपर। लेते हैं खुद नहीं ले जाते हो, सब वहां से मिलता है, पेन भी, पेपर भी, और जो भी चीज है तुम कुछ भी नहीं ले जा सकते हो अंदर। हाँ, डेफिनेटली। ओएमआर शीट वाला जमाना खत्म हो गया बहुत पहले। हाँ, पेन भी वही लोग देते हैं, वापस ले लेते हैं। हाँ, ठीक है, चलो ओके, बाय बाय। कितने पेजेस मिलते हैं ऐसे तो कोई नंबर ऑफ पेजेस का रिस्ट्रिक्शन नहीं होता होगा, बट यूजुअली आपको टाइम भी वेस्ट नहीं करना चाहते हो पेजेस लेने में, इसीलिए। कहाँ गया अमन? हाँ, यस अमन। नॉन अकेडमिक टॉप वाले हो ना तुम, तुमने बोला था नॉन अकेडमिक टॉप। बोलो। हाँ, हाँ। हाँ, कोई नाम तो नहीं पढ़ाते सर। तो एक सजेशन तो ये है कि सर के वीडियो जब देखते हो तो तुम्हें मालूम है यूट्यूब पे तुम स्पीड इंक्रीज कर सकते हो, प्लेबैक की स्पीड इंक्रीज करो, और ये तुम्हें स्क्रीन जब भी तुम आगे पीछे करते हो ना, जब उसको वीडियो के टाइमलाइन को चेंज करते हो तो तुम्हें समझ में आएगा कि अभी स्क्रीन पे सर थ्योरी पढ़ा रहे हैं, प्रॉब्लम सॉल्व करा रहे हैं, तो उससे तुम्हें आइडिया लग जाएगा। जनरली फॉरवर्ड बटन प्रेस करते हो तो तुम्हें समझ में आता जाएगा कि ये मेरे काम की चीजें आ रही हैं। बट डेफिनेटली फास्ट पेस्ड स्पीड पे फॉरवर्ड करो और अकॉर्डिंगली देखो, लाइव मत देखो, क्योंकि लाइव में तो एक्चुअली तुम्हें उसी स्पीड पे देखना पड़ेगा जिस स्पीड पे चल रहा है ना। तो कर सकते हो, बिल्कुल कर सकते हो, नॉट नॉट अ बैड आइडिया। ओके, सर शिमोन सर ने कहा पेज लेने में शर्म आती है वहाँ, अब वो तो पर्सन टू पर्सन डिपेंड करता है ना राजकुमार। ये सर्वेंट सर इज ऑसम टीचर, डेफिनेटली नो डाउट अबाउट दैट। Sir, but how will we see which question I have to attempt or not in JEE by clicking on each question? It would be hectic. Stephen, that's the part and parcel of learning to prepare for JEE examination. And that is why I always say that JEE examination is not only the test of your knowledge of the subject. It is also the test of your thought process about how do I attempt, how do I keep an eye on 90 questions simultaneously, which question I need to actually go back and see multiple things. And that is why it's a long process of 2 years. Yes, Siddharth. Mm-hmm. सेकंड क्वाड्रेंट आंसर था. हाँ हाँ, वेलोसिटी फर्स्ट क्वाड्रेंट में. पार्टिकल पूछा है. नहीं नहीं नहीं, क्वेश्चन में पूछा है पार्टिकल कौन से क्वाड्रेंट में, वेलोसिटी नहीं, पार्टिकल. अरे वेलोसिटी की बात हो रही है, एंगुलर वेलोसिटी तो पिक्चर में नहीं है क्वेश्चन में कहीं. ये है वेलोसिटी वेक्टर जो तुम बोलना चाह रहे हो. लेकिन पार्टिकल जा कैसे रहा है, क्लॉकवाइज. ठीक है, तो अब पार्टिकल को चारों क्वाड्रेंट्स में एक बार रख के देख लेते हैं. एक बार यहाँ, एक बार यहाँ, एक बार यहाँ और एक बार यहाँ. ठीक है, और अब वेलोसिटी वेक्टर को यहाँ से हटा देते हैं फॉर मोमेंट. तो देखो जरा वेलोसिटी वेक्टर ड्रॉ कैसे होने वाला है. ये है वेलोसिटी वेक्टर, वेलोसिटी वेक्टर सही बना रहा हूँ. सारे वेलोसिटी वेक्टर्स को ध्यान से देखना. क्या ये चारों वेलोसिटी वेक्टर अप्रोप्रिएट लग रहे हैं, है ना. अरे कहाँ गया, यूजर नॉट प्रेजेंट इन द क्लास. सर बट हम जेई में उनसे शीट मांग सकते हैं ना. हाँ बिल्कुल मांग सकते हैं. सर फिजिक्स में फॉर्मूला नोटबुक बनाया या नहीं, क्योंकि सर मैं फॉर्मूला भूल जाता हूँ. अरे एब्सोल्युटली बनाना है फॉर्मूला नोटबुक. सर हाउ डू पीपल रिमेंबर व्हिच क्वेश्चन केम इन द जेई एग्जाम एंड टेल यू ड्यूरिंग जेई पेपर डिस्कशन. सो यूज्ड टू ऑफ इट. That's right. So, do topper batch or normal batch do really matter? I do not think so. It does not matter to me. If it matters to you, that's a different thing. It ideally does not matter. Sheet क्योंकि same teacher will teach you यार. थोड़ा सा difference ये आता है कि तुम किन students के साथ पढ़ रहे हो. That's the only difference. Okay. Okay. हाँ आदित्य. Good evening. जो माइक्रोफोन है ना उसके थोड़ा पास आ जाओ. थोड़ा और जोर से बोलो. If I'm getting your question right, तुमने लेट ज्वाइन किया है इसलिए पहले वाला जो चीजें हैं उसके कॉन्सेप्ट अभी उतने से क्लियर नहीं है, राइट. हाँ तो डेफिनेटली अगर तुमने लेट ज्वाइन किया है तो दैट टाइम व्हिच यू हैव मिस्ड यू हैव टू कवर अप. और उसे कवर अप करने के लिए तुम्हें एडिशनल एफर्ट्स डालने पड़ेंगे. तुम्हें जितना भी टाइम आइडियली अभी आप दे रहे हो पढ़ने के लिए, उसमें हर रोज कितना और टाइम दे सकते हो फिगर आउट करो. शुड बी अकॉर्डिंग टू मी. जितना ज्यादा टाइम एडिशनली दे पाओगे उतना जल्दी तुम क्लास के साथ पैरेलल आ जाओगे. जितना ज्यादा अभी एफर्ट्स डाल लोगे तो अगर 1 घंटा दे पाओगे और मान लो कवर अप करने में 2 महीने लगे, तो अगर वही टाइम तुम 2 घंटा दे पाओगे तो कवर अप 1 महीने के अंदर हो जाएगा. दैट्स व्हाट आई एम ट्राइंग टू से. सो इट इज योर स्पीड विद व्हिच यू विल हैव टू कवर अप. हाउ डू यू कवर अप? बाय वाचिंग द रिप्लेस ऑफ द वीडियोस. मे बी इफ देयर आर माइक्रो कोर्सेज रनिंग, माइक्रो कोर्सेज हमेशा चलते हैं वेदांत में, वो लाइव होते हैं, तो तुम वो लाइव माइक्रो कोर्सेज भी अटेंड कर सकते हो ऑफ एनी टीचर बाय द वे. और वो अटेंड करके तुम बहुत सारी चीजें लाइव समझ सकते हो. ठीक है. दूसरा, तत्व सॉल्व करना इज द रियल थिंग दैट यू नीड टू डू व्हेन यू आर वाचिंग एनी ऑफ द रिप्लेस और एनी क्लास. खुद से तत्व सॉल्व करना सबसे ज्यादा इंपॉर्टेंट है. इसलिए तो बोल रहा हूं, कॉन्सेप्ट क्लियर होने का सिंपल सा मतलब है यू हैव टू स्टडी इट. एंड बाय स्टडीइंग एटलीस्ट यू आर ऑन वेदांतु की तुम रिप्लेस दे सकते हो या फिर वेदांतु के माइक्रो कोर्सेज लगा सकते हो. अगर ये फिजिकल क्लास होती तो बहुत चैलेंजिंग सिचुएशन में होते हो. ठीक है. सो डेफिनेटली थोड़ा थोड़ा पुश मारो, थोड़ा सा एडिशनल टाइम दो. हर रोज अगर 1 से 1.5 घंटा निकाल पाओगे तो कंसिस्टेंटली ऐसा करते जाओ. 1.5 महीने का काम आराम से तुम 15 से 20 दिन के अंदर निपटा सकते हो. बस बढ़िया. तो अगर लॉज ऑफ मोशन और वर्क पावर एनर्जी यही 2 चैप्टर के लागे, फटाफट से स्पीड बढ़ाओ और कर लो. ठीक है. ओके. सर आपने ओएमआर वाला टेस्ट दिया था. सीबीटी हमारे टाइम पे सिर्फ सीबीटी ओएमआर ही होता था. सीबीटी पहली बार मेरे बैच के साथ में बिग सैट स्टार्ट हुआ था पहली बार कंप्यूटर बेस्ड. आगे तुम वापस. हाँ तो अब एबीसीडी चारों वेलोसिटी सही लग रहे हैं और तुम्हारा जो वेलोसिटी वेक्टर है वो किससे पैरेलल लग रहा है, एबीसीडी में से डी है. तो यहाँ पे तुम्हारा पार्टिकल है क्योंकि ये है वो वेलोसिटी. इसलिए आंसर था सेकंड क्वाड्रेंट. परपेंडिकुलर तो फिर आंसर है जेड एक्सिस. ठीक है. ठीक है. एक मैग्नीट्यूड है और एक डायरेक्शन के साथ है. दैट्स इट. कोई डिफरेंस नहीं. ठीक है. दैट्स इट. ओके. सर यूज द शीट को हम घर ले जा सकते हैं. हाँ जेई के एग्जाम में दे डोंट इवन लेट यू टेक योर शीट्स. 45 पे कौन सा क्वेश्चन था, ये वाला क्वेश्चन. इसमें अंडरस्टैंडिंग का प्रॉब्लम हो रहा है. तो यार अंडरस्टैंडिंग का प्रॉब्लम तो बहुत आसान है यार. हमें ये पता होना चाहिए कि फ्रीक्वेंसी जो है वो 1/t होती है. लक्ष्य पांडे 1/t होती है. अब दोनों साइड पे अगर मैं 2 से मल्टीप्लाई कर दूं या नहीं भी करूं तो मुझे ये तो पता है ना कि टाइम पीरियड जो होता है वो 2 होता है. ये पता है. नहीं वो पुलिस नहीं, एक्चुअली मेरे घर के पास में हॉस्पिटल है तो बहुत फ्रीक्वेंटली एम्बुलेंस जाती है. हाँ तो ये भी पता है. तो यहाँ से टाइम पीरियड का फॉर्मूला इधर पुट करोगे तो ये बनेगा ω/2π. दैट्स इट. तो मुझे अगर ओमेगा मिल गया तो फ्रीक्वेंसी मिल जाएगा ना. लक्ष्य ओमेगा मिल गया तो फ्रीक्वेंसी मिल जाएगा. और ओमेगा निकालने के लिए मुझे ये वाला एक्सप्रेशन यूज करना था. दैट्स ऑल. सेंट्रीपिटल फोर्स की एक्सप्रेशन से फाइंड आउट करना था. तो कर लिया. फिर तो मैथ्स उसके अलावा. सर वो शीट्स को क्यों नहीं ले जाने देते, हम कैसे याद रखेंगे हमारे आंसर्स एंड स्टेप्स एंड ऑल. एक बार एग्जाम दे दिया उसके बाद में यू एंड दे डोंट केयर व्हाट यू रोट व्हाट यू डिड नॉट. ओके. ओके हृदय. सर आपको कैसे पता चला कि 2π से मल्टीप्लाई करना है? मुझे नहीं पता चला. मैंने इसलिए बोला ना कि चलो नहीं पता था. तो टाइम पीरियड को 2π/ω लिखते हैं. लिख दिया. दैट्स ऑल. सर व्हाट इज वेव बुक? जो ये स्लाइड्स तुम्हारे सामने ये वेव बुक कहलाती हैं. सो यू हैव डिनर. नहीं आई विल हैव डिनर नाउ. सर आई एम नॉट एबल टू मैनेज माय कोचिंग एंड वेदांतु प्रो क्लासेस. वेदांतु प्रो के साथ तुमने कोचिंग लगा रखी है, मतलब महान हो तुम. वेदांतु प्रो क्या फिर? हाँ स्नेहल व्हाट इज वेदांतु प्रो फॉर यू देन? हाँ भाई फिर वो कोचिंग के जो डाउट्स है उसके लिए एक बार कोचिंग लगानी पड़ेगी. फिर प्राइवेट ट्यूशंस बहुत से लोग करते हैं. कोटा में बहुत लोग करते थे. The parents force me to do so. अरे यार, you should actually speak to your parents or make your Sam speak to your parents. It's very important यार. You have limited time. If you will keep on giving that time to classes, तुम खुद से सेल्फ स्टडी नहीं कर पाओगे. जेई इज ऑल अबाउट सेल्फ स्टडी फंडामेंटली. जेई का एग्जाम किसको लिखना है? तुम्हें. तो जेई की स्टडी किसको करनी है? तुम्हें. तो जेई के कॉन्सेप्ट किसको क्लियर होने चाहिए? तुम्हें. और अगर वही नहीं कर पा रहे हो तो कैसे होगा? ठीक है. ट्राई टू टॉक टू योर पेरेंट्स. ट्राई टू मेक देम अंडरस्टैंड. फंडामेंटली अगर खुद को टाइम नहीं दे पाओगे तो फिर खुद को टाइम से मतलब सेल्फ स्टडीज को टाइम नहीं दे पाओगे तो फिर तो डेफिनेटली बहुत चैलेंजिंग होगा. यस विहान, बाय. यस स्नेहल, स्पीक टू योर पेरेंट्स. ओके, ये वाला वीडियो दिखा देना इतना सपोर्ट अपने पेरेंट्स को, शायद वो समझ जाए. ओके, स्नेहल के पेरेंट्स के लिए बोल रहा हूँ. इट्स इंपॉर्टेंट कि स्नेहल अपने सेल्फ स्टडीज के लिए टाइम निकाल पाए. और आइडियली वेदांतु प्रो इज प्रोवाइडिंग दैट स्टडीज which are additionally required for JEE preparation. So if you are putting Snehal to take more classes, that's actually consuming his time, his or her time. I don't know, Snehal is a girl or boy. So you need to actually give Snehal that time for self-study, and that's what you guys need to figure out. Okay. ठीक है. बच्चा पार्टी. Time to. Okay. Some people are still unmute. No one unmuting request is there. Yes, Nikhil. कौन से चैप्टर का है? हाँ. अभी पढ़ा नहीं हमने ये. अभी पढ़ा नहीं हमने ये. हाँ, पढ़ा नहीं हमने. This is actually vertical circular motion. मैंने बोला vertical circular motion will be the fourth session. The one which acts towards the center is centripetal. The one acts towards the tangent. अगर velocity constant है तो सिर्फ centripetal acceleration होगा. अगर velocity constant नहीं है तो दोनों होंगे. Centripetal v square by r होगा, omega square r होगा. Tangential rate of change of speed के बराबर होगा. That's it. ये कांस्टेंट है. एब्सोल्यूट कांस्टेंट गिवन है. हाँ, तो साफ साफ 80 दे दिया ना. अरे साफ साफ लिखा है, जब कभी भी स्पीड चेंज हो रही है तो टेंजेंशियल एक्सेलरेशन होगा. अगर स्पीड चेंज नहीं हो रही है तो टेंजेंशियल एक्सेलरेशन नहीं होगा. और सेंट्रिपेटल एक्सेलरेशन को स्पीड से सिर्फ इतना सा काम है कि मैग्नीट्यूड ऑफ स्पीड कितना है उसका स्क्वायर करो और रेडियस से डिवाइड करो. दैट्स इट. और डायरेक्शन तो बताइए. सेंट्रिपेटल टुवर्ड्स द सेंटर, टेंजेंशियल टुवर्ड्स टेंजेंट. ओके. हाँ, रेवोल्यूशंस पर मिनट जो है वो है 2 पाई रेडियंस डिवाइडेड बाय 60 सेकंड्स. मिनट्स 60 सेकंड्स के बराबर होता है. रेवोल्यूशन में एक रेवोल्यूशन में 2 पाई एंगल कवर होता है 360 डिग्री. दैट्स व्हाई. ठीक है. सिद्धार्थ says sir in uniform circular motion centrifugal force is 0 ना. if you are looking at it from the non inertial frame of reference अगर तुम होल बॉडी पे तो सेंट्रिपिटल फोर्स का मैग्नीट्यूड सेंट्रिफ्यूगल फोर्स के बराबर होगा. हाँ अंश, बिल्कुल ऐसा होता ही है. So no sir, I did talk to Harsh sir and he helped me. Wow, that's great Nihal. Very happy to know that. If not then as in what? क्या पूछना चाह रहे हो मैं समझा नहीं. पर्सन यानी ऑब्जर्वर. हाँ, तो फिर कोई सेंट्रिफ्यूगल फोर्स होगा ही नहीं. सेंट्रिफ्यूगल फोर्स सिर्फ और सिर्फ नॉन इनर्शियल फ्रेम ऑफ रेफरेंस में कंसीडर किया जाता है. ठीक है. ठीक है गाइस, चलो टाइम टू से गुड बाय, गुड नाइट, सी यू ऑल नेक्स्ट टाइम. सेशन नंबर 4 में मिलेंगे, सेशन नंबर 3 में मिलेंगे और बात करेंगे मोर अबाउट सर्कुलर मोशन. टिल देन टेक केयर, बाय. हasta la vista गाइस, साइनिंग ऑफ, गुड नाइट. ओके, बाय बाय गाइस.